Hello everyone. I am so honored to be with you to communicate academic questions and ideas. The title of the paper I am presentation is Mongolian Word Segmentation based on BiLSTM CNN CRF model. I shall only take 15 minutes of your time. I will talk about the topic on the preparation of Mongolian word segmentation. First of all, I want to introduce myself. I come from the Mongolian Normal University. The content is listed as follows. I will report on the 4 areas of introduction, method, results, and conclusion. Firstly, the first part, introduction. The background and significance is divided into 3 parts. Natural language processing of ethnic minorities has become an indispensable, important research field. Mongolian word segmentation is the basis of Mongolian information processing. Neural network word segmentation methods are widely used in other languages, but the existing Mongolian neural network word segmentation methods are relatively few. In terms of segmentation of inner Mongolian words, a dictionary-based Mongolian word segmentation method was first proposed in 1997. In 2005, the rule-based Mongolian word segmentation method was proposed. Since 2009, the rule-based Mongolian word segmentation method has become popular. In 2011, MiddleWARE applied a combination of dictionary rules and statistics to the Mongolian word segmentation task. Starting in 2019, neural network methods has been applied to Mongolian word segmentation tasks. Next is the second part, the experimental method. The commonly used Mongolian scripts are traditional Mongolian and Latin Mongolian. These 2 Mongolian scripts represent 2 completely different written forms. In order to facilitate the processing, I converted the traditional Mongolian Unicode encoding method into the corresponding Latin characters according to the Latin transliteration corresponding rules. The corresponding relationship of part of the transliteration is shown in the figure on the right. The correct conversation between traditional Mongolian and Latin Mongolian is an important step in data labeling. In word segmentation, each character in the corpus needs to be marked with a single point. In the experiment, 4 taggers B, M, E, S were used for tagging, where B represents the root, M represents the middle of the word, E represents the configuration suffix, and S represents a single character. The results of labeling of a Mongolian word with 4 categories B, M, E, S are shown in the table. The first line is a single Mongolian character sequence converted from Mongolian sentences, and the second line corresponds to Mongolian characters. Label the sequence. As can be seen from the table, the Latin form and the segmentation granularity of this Mongolian word, the corresponding segmentation result is hukji glu hu, the root is hukji, and the configuration suffix are glu and hu. In the word segmentation model of BiLSTM, Since the softmax only selects the label with the highest probability for output, words with incorrect grammatical structure will be generated. In order to solve this problem, I combined BiLSTM and CRF. The main function of the CRF layer in this combined model is to correct the Mongolian word segmentation results predicted by softmax. On this basis, CNN is added to extract local features of words. As shown in the figure, the word-to-vector model is used in the first layer of the model to convert each Mongolian character into a dense, low-dimension character vector. In the second layer of the model, for each input sequence, the local feature representation of the word is extracted through the CNN network. The third layer of the model combines the local feature representation of the word with the pre-trained character vector and inputs it into the BiLSTM network. The last layer of the model adds the output of BiLSTM as input to the CRF and jointly decodes the optimal tag sequence. The third part is the experiment and results. The data set used in the experiment is a corpus provided by the Minority Language Word Segmentation 2017 activity. The size of the corpus is a total of 50,017 sentences and 850,000 words. The dataset is divided into training set and test set. The details of the division are shown in the table. Part of the data style is shown on the right. In this experiment, 3 combined matrices of precision, recall, and F-value were used to evaluate the performance of this model. The precision rate is percentage of the number of correct word segmentation to the total number of word segmentation. The recall rate is percentage of correct word segmentation to the total number of word segmentation in the test set. The F-value is harmonic average of the accuracy rate and the recall rate. The calculation formula is shown in the table. The dimension of the vector is very important to the accuracy of Mongolian word segmentation and the speed of model training. The first experiment verifies the influence of the vector dimension on the performance of the model. After experimental verification, the best effect is when the dimension of the character vector is 100. A vector that is too long will increase memory consumption and prediction speed, and a vector that is too short cannot fully express the semantics. Through the second experiment, the influence of the dropout value on the performance of the model was examined. The experimental results found that when the ratio of the dropout value is set to 20%, the performance of the model is the best. Dropout can delete some nodes immediately. If the value is too large, it will reduce the fitting ability of the model, and it will not work if it is too small. The third experiment compares the performance of different models on word segmentation tasks. The experimental results show that the BiLSTM model is more suitable for the Mongolian word segmentation task than the LSTM model. The BiLSTM CNN CRF Mongolian word segmentation model uses the BiLSTM model to extract the context information of the character sequence, uses the CNN model to extract the local feature information of the characters, and uses the CRF model for constraint correction, and the final F value is the highest. The fourth part is my conclusion. In the Mongolian word segmentation task, the CRF layer is added after the BiLSTM layer in the model structure, which can learn the context information of sequence tags and the constraint rules between tags, thereby improving the word segmentation effect of the model. On this basis, CNN is introduced as a local feature extractor of Mongolian words so that the model can effectively learn the local features of Mongolian words, thereby improving the segmentation effect of Mongolian words. In the future, on the basis of this research, we will further realize the Mongolian sequence tagging framework that integrates Mongolian word segmentation, part of speech tagging, and named entity recognition, provide service for the follow-up Mongolian natural language processing research. This is the end of my report. Thank you for listening.